will solve this equation, which I've let you do since test 1. Remember, test 1, you were already solving that. That gives you the x-intercepts. When you keep going, where your Casio will tell you those two numbers. So your Casio will tell you this, and whether it's up or down. Because once you know the vertex is at the top or the bottom, you also know the shape of the U. The only thing it won't tell you is the y-intercept. The y-intercept you can get by looking at it, because all you got to do is cross that out. Here's the y-intercept when x is 0. So in other words, there's not a lot of work here. So, what about these? That's just called the, I don't know if it has a name, that's just a regular quadratic, you know, ax squared plus bx plus c. So what about these annoying ones? Well, if you leave it alone, you can get the information. But if you wanted to use the same technique we're using here, you would have to multiply that out to make it look like the other form. So if I wanted to, I could say x minus 3 times x minus 3 minus 9. That's x squared minus 6x plus 9 minus 9. That's x squared minus 6x. And I have a is 1, b is negative 6, and c is 0. So I would go a is 1, b is negative 6, and c is 0. And 6 and 0, there's my x-intercepts. Minimum is 3, negative 9. So there's all that information still in there, but you can't get it until you put it in the other form. So if you want to use Casio, it has to look like a normal quadratic. Yeah?
Question on number 3.
Well, let me see. Can I scroll away from this? So you can make them all look like the regular ax squared plus bx plus c. Or you can just play it as it lays. If it's in vertex form, you can get the information from there. If it's in the other form, you can get the information from your calculator. You can do both techniques. Now, I am going to ask you, I am almost positive, on the test, to put something into vertex form. Okay? And the reason I'm going to ask you that is because it's one of those techniques that you'll need later on in your life. If you continue on in math, not in your real life, in your math life. I can scroll now, right? Yeah. Okay.
So I get how you ask why equals -5, but what I'm not understanding is how did you find the exact point for the other side?
It's, you go, here's -5. I count how many steps to get to the line down the middle. How many steps? 1, 2, 3.
So you just do the same on the other
Yeah,
side?
1, 2, 3. That's what symmetry means. If you were to think of that dotted line as a fold.
So in order to plot the other y, you need to check out the axis of symmetry.
You need to know where the center line is. You need to have that. You need to eyeball where that is, right down the middle. It's right from the vertex down. See, every point matches from side to side. So here we go. So you can start your life by typing if you wanted to. You can go right to this Casio, right? Once you tell me that you're actually going to find the vertex by doing this, yeah, right. Give me all sorts of information because that's positive. I know this thing goes up. And then I can say x is equal to negative that tells me the vertex is at 1, 0. And I'm at 1, 0, and I'm going up. So now for the x-intercept, y be 0, so I'm solving this, which is this, x equals 1. There's only one x-intercept right there on the axis. To find the y-intercept, I let x be 0, so then I would have 0 squared, 2 times 0 plus 1. Those are gone. And I have y equals 1. So it's here. There's another one here. Like that. That's doing a lot of stuff on here. But if you type this into your Casio, the first thing it'll tell you is x equals 1, x equals 1, meaning there's only one intercept. It's at 1. The next thing it'll tell you is this, and it'll tell you in this case it's a minimum. Right? You doing that? You just believe it? That's the way I've been going in this lecture. I would just believe it. So I have given you an example of everything that can happen to you here. This is everything that can happen to you with a parabola. Goes up, goes down. One x-intercept, 2 x-intercept, no x-intercept. Okay, these are all the different things that can happen. So you have a model for everything. So, what if, God help us, you needed to write this in vertex form? Writing it in vertex form is just the same thing you did with the circle. This is one of those things where you have to show me steps. Okay? Your calculator will obviously tell you what the vertex is, which means you could backwards engineer it to get the vertex form, but it's just like completing the square on test 1. The whole idea is the process. So, remember we had this problem also on test 1. What if you have a coefficient in front? Well, on test 1 we got to divide it out. This time around I have to factor it out. So you put the x's together and the constant by itself. I can't do this the same way I was doing the circle and the stuff on test 1 because I don't have a side to move it to. In other words, I don't have a number over here. That's f of x. So I have to keep everything on the same side. Okay? I'm still going to add and subtract, or I'm still going to balance this thing out, but I'm not going to do it by adding the same thing to both sides. Okay? So I complete the square here. So that's the same. Half the middle term, square it. So I write it in here. And now I have to keep this thing balanced. So if I just put 25 in, I also have to subtract it out. Except, I didn't just put 25 in. I put 50 in. Because I tucked it inside the parentheses. So I put 50 in. I have to subtract 50 off. So this becomes f of x equals 2 times x plus 5 squared minus 8. So, how can Mr. Casio? Well, let's look at this thing. So I have 2x squared, 20x, and 42. And I'm not interested in the intercepts, I'm interested in the vertex. So Cassio's telling me the vertex is -5 and -8. Okay, so that tells me that's the opposite sign. And that's the same sign. And I had, it's not telling me, here's the 2. All of those two had a 2 in front. Yes?
I got a little lost in this, the 50.
When I complete the square, so I put a 25 there. So in order to keep this thing balanced, whatever I put in, I have to subtract off. It's like if I had, y equals 2x plus 3, and I decide I am going to add 7, then I have to subtract 7 if I'm going to keep it the same. Normally I could do that on each side, but I'm trying to stay on the same side now. So what I do is I put my 25 in, but it's inside the parentheses. So it's 2 times 25 that's actually going in. I wrote a 25, but this 2 outside means it's 2 times 25, which is 50. I don't know any other way to explain it. This is the answer. This is the work. In other words, you can figure out the answer by either using your calculator or backwards multiplying. And that's not the point. The point is to see you complete the square. Yeah.
So if there wasn't a 2, it'd just be 25 on both sides.
Yes. Or 25 plus and 25 minus.
Yeah.
That's what's happening. Yeah.
I get the -8, but how did you get to, for the answer, how did you get from the top to the bottom?
X plus 5 squared. You get the last 2 questions right on the last test?
No.
Okay. There's the problem. This is X plus 5 squared. That's what completing the square does.
To the X to the 10.
That X squared, it's factoring. It's X squared plus 10x plus 25 is X plus 5 and X plus 5. Nothing happens to it. It's just, it literally, you're putting a number in because you want to factor it. You have one last chance. Okay. Fantastical against Tesla. This is it, your big show. Okay. So here's the thing I'm telling you about this. This is one question on the test. Don't make yourself batshit over this, okay? That's the most important thing. I see students focus on something to the point of absolute obsession. I need to understand this, I need to understand it. No, you don't. You can go through life just fine graphing parabolas without doing this, okay? This is one technique. On the other hand, if you can't graph a parabola, period, that's a problem. There's more than one of those, okay? But don't, go crazy over one question. Yeah.
It says whatever you added, you must also subtract. What part did you do?
Here, I added 50 and I subtracted 50.
No, it should.
Yeah, there's 2 of these. So if you're going to throw out that vertex thing because you finally decided, oh hell no, I've had enough to complete a square, I'm done with that, then you better know how to do word problems. A much different proposition. First of all, I can't give you a pattern to solve every word problem. It's not like doing the graphing. I can tell you step 1, step 2, step 3, step 4 for every single parabola graph. I can't do that with a word problem. They're all different. Every single time. It's analysis. It's a totally different skill. Okay? So, the only thing these things are going to share is they're not going to be word problems in the traditional sense that, you know, 2 trains leave a station. One goes east at 110 miles an hour, and the other one goes west at 10. And it's all sorts of formulas you have to know. No. These word problems are going to give you a function, ask you to find something about a minimum or a maximum, which means they're asking you about the vertex of a parabola. So in essence, it's stuff that you've been doing. Okay? This quadratic function describes the miles per gallon of a car driven at X miles per hour. So X is miles per hour. F of X, miles per gallon. So that's the first thing you should always write down. What's the input? What's the output? You know, define what you're going to find. Because I see too many people get to the end and they have X equals 4 and they go, okay, what the hell is that? You have to look at what's being described in the problem. Okay, so it's asking me for maximum fuel efficiency. I have a quadratic with a negative sign, which means it's a parabola and it opens downward. So if I find the vertex, I am finding the maximum. So, the vertex I have X equals negative B over 2A, which is negative 1.93 over 2 times negative 0.018. Here, so I have 2 negatives, I'm going to make it positive. Thank you. So I have 1.93 over 2 times 0.018. Decimal. So 53.6. Okay, that means you drive 53.6 miles per hour. But I guarantee you one of the answer choices would be you get 53.6 miles per gallon. Okay, in case you can't tell the difference between whether you're finding the X or the Y. What would your miles per gallon be at this speed? Miles per gallon means I go back to the original function and I plug it in. For those of you who insist on forgetting your calculator, you're going to be in big trouble with these problems. Look at it. I have negative 0.018 times 53.6. Oh my God. Squared plus 1.93 times 53.6. 6 minus 25.34. 26.4 we'll call it. And that is so according to that model, if you drive 53.6 miles per hour, you will get 26.4 miles per gallon. Yes, it's a word problem, but it's something about a parabola. They could ask you to find intercepts, they could ask you to find a vertex. They're only going to ask you to find things that you've already been finding when you're graphing. It's wordy, it'll have a lot of description attached to it, but it is not, by any stretch, anything creative. In other words, you'll be given the information.
Out of curiosity, are those squiggly equal signs different than the regular equal signs, or?
That's an approximation. That's the symbol for approximation. You can do this, or you can do this.
Will we specifically need to put that on the test for you
No,
to
'cause you're
know?
picking answers. You know, so-
So under review for the test, you're gonna give us some examples like word problems.
yeah, a lot of them. Bunch of them. Like 10, 12. Yeah. No, word problems you only get better at if you practice. I mean, if you have a lot of them.
Yeah, because they have different like terminology, so.
They're all weird. You know, half of it is getting through the language to figure out what the hell the question is. You know, it's a different kind of skill. It's an interpretive skill rather than just a pattern following skill. So yeah, that's usually, and part of the reason you suck at word problems is because in any given class, I mean, look, how many times have you factored by now? Thousands. By the time you leave an algebra class, how many word problems did you do? You'd be lucky if you ever did 100. I mean, it's completely disproportionate. If you had in your life in an algebra class had to do 1,000 word problems, of course you'd kill yourself, but I mean, you know, if you had ever had to do it at the same level, you would be better at word problems. You're just unfamiliar. Plus, you know, it's like listening to those. Don't you have friends that always make things sound complicated? That you're talking to and you're like, oh my God, just get to the freaking point. That's what word problems are. You're sitting there thinking, blah, 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 blah. Okay, and? So, this function models women's earnings as a percentage of men's X years after 1960. So, X equals what?
Years?
Years.
So if I get X equals 54, it's 54 years
Alright.
after 1960. That's the thing. So if I get X equals 10, the year is 1970. Okay? They do this a lot with years, okay, with amounts of time, because the numbers are really big. It's 1,960. I mean, we're used to seeing it as a year, but to make a model that has 1,960 as an input, they usually don't do. They usually have a base year, and then they can say 1 year later, 2 years later. So you're actually inputting much smaller numbers. Okay? But you have to realize, if they say, in what year did this happen? One of the choices might be 10. So that was what? In Jerusalem? Way back when? People were hanging? Yeah, you're 10. Here we are. Okay. No. 10 years after 1960. Okay. And f of x, what is f of x? What's going to come out? When I put in a number, a percent. Okay? So what's going to come out in here? Is the percent that women earn. So the number that comes out will be, if it's like 40, that will mean women earned in that year 40% of what men earn. If the number comes out to be 20, that'll be women earned in that year 20% of what men earn. So here we go. All I know is I'm getting a vertex. So first of all, that's positive. So that means it opens like that. So what I'm finding is a minimum. This says the function, you know, what year was the percent at a minimum? Okay? So they're asking me year. That means they're asking for x. So x is equal to negative b over 2a. So that is negative 0.4 over 2a. And that is 9.09. that means in what year was the percentage of minimum? 1960 was a year. Okay, and what was the percentage for that year? So that means I want the y value or the f of x value. So I'm going to plug in 9. It's going to be 0.0229 squared. Okay, so the percent was 58%. So if I had to give you an English sentence that described these numbers, okay? This is likely the only skill in your life you would actually have to use, unless you're going to be a total geek. Rarely is anybody in your actual life going to hand you something and go, hey, did you work out those two and tell me what X and Y are? They're going to give you data, and they're going to say, what does that mean? That's the skill that humans have. No computer's going to do that, okay? So the skill that you would have is to be able to say, in 1969, women earned only 58% from what?
That's it.
That is the English conclusion to what those numbers mean, which is, like I say, in real life, the important part. Okay? Anybody can get the number itself. Anybody can tell you, yeah, I got 9 and 58. What does that mean? 58 years ago, I got 9%? 9 years. Okay. It depends. They could have a sentence like that. There could be, give me a complete.